Bloomberg recently released a new language model called Bloomberg GPT. It's a 50 billion parameter large language model purpose built from scratch for financial applications. Let's try to summarize the details of the paper. Bloomberg used its extensive archive of financial data to create a comprehensive 363 billion token dataset consisting of English financial documents. The data was augmented with a 345 billion more tokens collected from public web. Using a portion of this training corpus, the team trained a 50 billion parameter decoder only casual language model. Notably, the Bloomberg GPT model outperforms existing open models of a similar size on financial applications by large margins. Instead of following the greedy merge-based subword tokenizers such as byte pair encoding or word peace, they used a unigram model. They treated data as a sequence of bytes rather than Unicode characters, and they included each of the 256 bytes as token. In a pre-tokenization step, the input byte sequence is broken into chunks by greedily matching the following regular expression. This is very similar to GPT-2 in preventing multiple characters from appearing in a single token. However, they also included space in the alphabet chunks, which allows multi-word tokens to be learned, including information density and reducing context lengths. They used a decoder-only casual language model based on Bloom. Bloom is a transformer-based large language model. It is considered as an alternative to OpenAI's GPT-3 with 176 billion parameters. The model contains 70 layers of transformer decoder blocks. The summarized parameters used in model is on the screen. Bloomberg GPT is a PyTorch model. To maximize the GPU utilization, they converted each training sequence of same length of 2048 tokens. To achieve this, they concatenated all the training documents with an end-of-text token as a document separator. They used the AdamW optimizer and used the cosine decay learning rate scheduler with the linear warm-up. Dropout was set to 0.0 in all layers. They used the technique of query key layer scaling, which was proposed to improve numerical stability of floating point 16 mixed precision. They used Amazon SageMaker service provided by AWS to train and evaluate Bloomberg GPT. It internally uses 8 NVIDIA 40GB A400 GPUs with NVIDIA NVSwitch internode connection. To train Bloomberg GPT, which has a larger memory footprint than available GPU memory, they rely on stage 3 of zero optimization. The zero redundancy optimizer is a novel memory optimization technology for large-scale distributed deep learning. Zero can train deep learning models with billions of parameters on the current generation of GPU clusters at least 3 to 5 times the throughput of the current best system. They use stage 3 of zero, which is a parameter partitioning in the model. The two other stages are optimizer stage partitioning and the gradient partitioning. Dense models with billions of parameters cannot scale efficiently on cloud environments with various networking conditions due to large communication overheads. They use mics proposed by Amazon to reduce communication overhead in cloud environments. To reduce memory consumption further, they used activation checkpoints. With activation checkpoints, only the layer input and output are kept in memory following a forward pass, while any intermediate tensors are discarded from memory. During the backward pass, these intermediate tensors may be recomputed. Fuse kernels were used for optimizing performance by combining several operations into a single GPU operation. This can reduce peak memory usage by avoiding storage of intermediate results in the computational graph as well as improve performance. They used a mask casual softmax fuse kernel in SMP in the self-attention module. To reduce the memory requirements, forward and backward passes are done in BF16 while parameters are stored and updated in full precision. They validated Bloomberg GPT on standard LLM benchmarks, open financial benchmarks, and a suite of internal benchmarks that most accurately reflect their intended usage. Their mixed dataset training leads to a model that outperforms existing models on financial tasks by significant margin, without sacrificing performance on several LLM benchmarks. So that's all from our side. Hope you liked the video. Please add comments if you feel that Bloomberg GPT has a lot of potential when it comes to financial applications. If you haven't subscribed to the channel, please like and subscribe and click on the bell icon for notifications.